Really need to pay attention to this problem because this type of problem comes up over and over and over again. So we've got a pasture that's enclosed by 180 feet of fencing on 3 sides. So 1 side, 2 sides, 3 sides. The 4th side's the barn, so we don't have to worry about that. So the barn's up here. But it's also divided into all of these sections, right? So we know that this thing has a length. It's a rectangle, right? It's got a length, and it's got a width over here, and it's got a width over here. But because we're dividing it into all of these sections, we need to use this 180 feet for all of these widths and the length. So the perimeter of this thing is really 1, 2, 3, 4, 5, 6 of these widths and the length, which means that our 180 feet of fencing needs to get divided among the 6 widths and the length, okay? What's the maximum area? So again, we're looking at a quadratic with a vertex, and what should the dimensions be to maximize the area? So in terms of a quadratic, my input is going to be, well, let's rearrange this thing and solve for L. So let's rearrange this guy and say L is equal to perimeter, which is 180, minus 6W. The area is, of course, length times width. It's just a regular rectangle. We don't care about the divisions when we're talking about area. But instead of L being L, I'm going to substitute in the 180 minus 6W. Right? So that's going to give me negative 6W squared plus 180W. So there's my quadratic. My input is width, so that would go on the x-axis. My output, of course, is area, so that's going to go on the y-axis. This thing opens down. Again, if we have no width, we have no area, so it's going to look something like that. We need a maximum, so we need the vertex. We need this ideal width that gives us the maximum area. So h is going to equal negative b over 2a. Let's see what 180 divided by 12 is. That gives us 15. So we need a perfect width of 15. In this case, we're using feet. And then our area is going to be our width of 15 times 180 minus 6 times the 15. Let's plug that in the calculator and see what we get. And we get an area of 1,350 square feet. Okay, so A, what is the maximum area of the outside rectangle? 1,350 square feet. And B, what should the dimensions be of the outside of the rectangle? So that's just one width and one length. The width we know is supposed to be 15 feet. Let's go back up to here. So we had, oh, here we did this. L equals 180 minus 6W. So if L equals 180 minus 6W, we can plug in 15. 180 minus 6 times 15. And the calculator gives us 90. So we have a length of 90 feet. So here's our answer to A. And here's our answer to part B.